Hello everyone, we're back with another paper today. Today we're solving this math paper. This is 9709 paper 3-2 from the May June 2024 series. The time is 1 hour 50 minutes. You have access to MF19. This is paper 3, pure mathematics 3. Okay, so we're launching P3 paper after a long time. I'll be doing more of physics, chemistry, and bio throughout this month, as well as more math, so don't worry. I'm trying for uploads every day of the week. So before we start, I actually have some good news for you guys. We're actually launching the first physical location for CI paper solve starting from February, hopefully. The location will be in Dhaka, Bangladesh, in Dhanmondi. So if you're from here, if you're a Bangladeshi student, please consider joining. Batches of 4 friends join together get discounts. We're going to be having revision batches for all subjects. And if you want to join individual components, that's also fine. Classes will be hybrid. You can attend offline or online, and recordings will be provided after the class. Also, I'm going to be taking mocks, and mocks start at 80 USD or 9,500 BDT. It's just a one-time payment for 3 months of exams and solution classes. Plus, you get access to asking me questions anytime for any problems you have. So please, if you are interested, consider signing up. I'll drop a link in the description. You can just sign up the form and I'll contact you and provide more details, or just email me if you're if you want more details. Anyway, that's it. So I think we should start. Let's go. So let's take a look at the threshold. This is component 3-2. Here you go. This. So for component 3-2, we saw that out of 75, A is at 48, B is at 39, C is at 30, D is at 23, E is at 14. Okay, so that's that. So A star should be somewhere so A star, where should it be? As you can see, it's like 9 marks above this, so 9 marks plus this, that's 57. A star should be at 57. Okay, so yeah, pretty average paper, I guess. But component 3-1 and 3-2, these were harder than component 3-3. Okay, so let's start. Let's sketch the graph of this where A is a positive constant. Let's go. Let's start. We can do this. So y is equal to x minus 2a modulus. So essentially x minus 2a. So when y is equal to 0, x is equal to twice a, and when x equals to 0, y is equal to minus twice a. Okay. So if this is twice a, this is minus twice a, so the graph should be like this basically. But yeah, due to it being a modulus, it's just going to be a reflection on the x-axis. So this is the graph that we're aiming for. This is our answer. Solve this inequality. 2x minus 3a is less than this. So the other graph is 2x minus 3a. This is a, this should be 3a. So twice x minus 3a. When x equals to 0, y equals to minus 3a. When y is equal to 0, twice x equals to 3a, x equals to 3 by 2a. When x equals to 0, y is minus 3a. Minus 3a. Okay. Fine. So it's not a modulus, it's going to be straight. 3 by 2. So where's 3 by 2? 3 by 2, this is a, right? So 3 by 2 should be over here. So let me use this color. It's basically this. essentially it's this. There you go. So it essentially intersects at a single point, which is this, with the modulus component. So you can just do this. So you can write 2x minus 3a is equal to the modulus of this, which is minus x plus 2a. So we actually get 3x is equal to 5a, or x equals to 5 by 3a. That is the answer. So now the inequality. I want this to be less than the modulus graph, less than it. So if you go to the left hand side of this point, then the line is actually below the modulus line. So it should be x is less than 5 by 3a. That's the logic. And if they wanted this greater than, then it would be to the right. So it would be greater than 5 by 3 then. Okay. Next, express this in partial fractions. Okay, so at first, look, it's a proper fraction. Sorry, it has 2 on top and 2 down below, so we can solve it. So we can write this as x squared minus 9x minus 16 divided by 2x squared minus 5x minus 12. Okay. So let's break this down. So since the power is the same, we will have a constant. Okay, since the power is same, we will have a constant. And in the one below, we actually have to do middle term breaking. See this 2x squared minus 5x minus 12. So what is this? 24. 24. So 8 and 3. 2x, so that's x minus 4 plus 3 x minus 4, 2x plus 3 x minus 4. So I'll just edit this. Okay, it should be 2x plus 3 x minus 4. So it's very straightforward. Since there's no square involved, it's just going to be 2x b by 2x plus 3 plus c divided by x minus 4. There you go. Okay, so now let's just go ahead. A will be multiplied with both of them. B will just be multiplied with this. C will be multiplied with this. And down below we have this. Fine, so we can get rid of that. So basically this is our end result. We have this over here. Okay, so let's do this. When x equals to 4, 16 times 6 is 96, minus 36 minus 16 is equal to 0 plus 0 plus 8, 2 4 is 8 plus 3 11c. 96 minus 36 minus 16 divided by 11, so c is 4. Next, when x is equal to, I'm just trying to make this 0, yeah, so minus 3 by 2. Okay, so this is minus 3 by 2 whole square into 6, which is 13.5. Then minus 9 into minus 3 by 2, which is plus 13.5 minus 16 is equal to 0, plus this turns into b into minus 5.5 plus 0. Okay, so 13.5 into 2 minus 16, which is 11. 11 is equal to minus 5.5b, so b is basically minus 2. Now to find out the last one, we can just use any value. We can go for x equals to 0. So 0 plus 0 minus 16 is equal to a 3 times minus 4 plus b minus 4 plus c just 3. Okay, so minus 16 is equal to minus 12a minus 4b, which is plus 8 plus 12. So minus 12a is equal to minus 16 minus 8 minus 12, which is minus 36. So a is equal to plus 3. So that's that. So we have our final answers. A is plus 3, B is minus 2, and C is 4. Great. That was it. Now the variables x and y satisfy the equation a to the power 2y minus 1 is equal to b to the power x minus y. Show that the graph of y against x is a straight line. Okay. A to the power 2y minus 1 equals to b to the power x minus y. Let's do this. Let's apply ln. Okay. So ln a to the power 2y minus 1 equals to ln b to the power x minus y. So 2y minus 1 ln a is equal to x minus y ln b. Now 2y ln a minus ln a is equal to x ln b minus y ln b. Fine. Now we have to bring y together. 2y ln a minus y, plus y ln b is equal to x ln b plus ln a. Take y common. 2 ln a plus ln b is equal to x ln b plus ln a. So yeah, this actually matches the equation y is equal to mx plus c, right? Essentially. Or you can write this y is equal to ln b divided by 2 ln a plus ln b times x plus ln a divided by 2 ln a plus ln b. So you can say that it matches y is equal to mx plus c. That's it. Therefore, it must be a straight line. You have to write this. Okay. Given that a is equal to b cube, state the equation of the straight line in the form y is equal to px plus q. So a is equal to b cube. So why don't we write this? Y is equal to ln a. Actually, let's solve this part. I think it should be easier. A is equal to b cube. So y 2 ln b cube plus ln b to x ln b plus ln b cube. 6 ln b plus ln b. Okay. Y into 7 ln b so what we can do is just remember this ln b by 7 ln b plus 3 ln b by 7 ln b. Okay. This is what you end up with. Okay, this is the general idea. Now it's very straightforward. You can just get rid of these. So you end up with y is equal to 1 by 7 x plus 3 by 7. This is your answer. Okay, makes sense. The equation of a curve is this: find the gradient of the curve at point y is equal to 1. Okay, implicit differentiation, right? So dy by dx, and I'm keeping this normal, plus now I'm keeping y normal, 2 to the power 2x. I just differentiated this. Next, 2y times dy by dx I'm differentiating this and keeping this normal, plus keeping y square normal and differentiating that, which is just e to the power x, is equal to 0. Now keep all the dy by dx on one side. Dy by dx e to the power twice x plus 2y e to the power x into dy by dx is equal to minus y square e to the power x minus y 2e to the power 2x. Okay. Next, dy by dx e to the power twice x plus 2y e to the power x is equal to minus y square e to the power x minus 2y e to the power twice x. So finally you end up with dy by dx is equal to minus y square e to the power x minus 2y e to the power twice x divided by e to the power twice x plus 2y to the power x. And you know that where y is equal to 1, so let's just input that. So we can find out the value of the x coordinate as well. So 1 e to the power twice x plus 1 e to the power x equals to 6. Okay. So we have to form a quadratic equation actually. Let's just solve this over here. Wait. Solve this on the side. So e to the power twice x plus e to the power x minus 6 equals to 0. So a polynomial 1 1 minus 6. So we are only getting this solution. Two actually. One of them is this and the other is this. So 1, the other is this. However, this is not applicable because ln minus 3 is not real. It's not possible. So we get this. So we have the coordinate and we can just apply it over here. So dy by dx equals to minus 1 square e to the power x is 2 minus 2 into 1 and e to the power twice x should be 2 times 2, which is 4 divided by 4 again plus 2 times 1 times just 2. So what are we getting? Minus 2 minus 8 divided by 4 plus 4, so minus 10 by 8. So it's minus 5 by 4 or minus 1.25. That's our final answer. Okay. Moving on to question 5. It is given that the equation e to the power twice x equals to 5 plus cos 3x. It has only one root. Show by calculation that this root lies between these coordinates. Okay, let's form a function first by bringing everything to one side. So I'm going to apply 0.7 once and I'm going to apply 0.8 the other time. Let's do this. Okay. Make sure your calculator is in radians. So e to the power twice x minus 5 minus cos plus 3x. Okay, 0.7. This is minus 0.43995 and 0.8. That's plus 0.69043. So since the sign changed, okay, since the sign changed between these two values, that's why the root lies in between these values. Okay, so you have to state that like this. Since minus 0.43995 is less than 0 and plus 0.69043 is greater than 0, the root lies in this interval. Okay, that's it. Fine. Show that if a sequence of values in this interval is given by this iterative formula, it converges to that. Okay, so let's do this. X equals to half ln 5 plus cos 3x So twice x equals to ln 5 plus cos 3x. Okay. Next, you can bring the e to that side. E to the power twice x equals to 5 plus cos 3x. Oh yeah, we are here. That's it. Shown. Very straightforward. Use this iterative formula to determine the root. Give the result of each iteration to 5 dp. Okay. So x1, we can use 0.7 since it was given. Write down this in the calculator. So it's a half ln 5 plus cos 3x. Let's go. Let's start with 0.7. So x2 is 0.25 dp, right? 75150. The next, I'm applying the answer again from the calculator. 0.73719, 0.74105, 0.74000 basically, 0.74028. Essentially we have reached the answer. So the value of x should be to 3 dp is 0.740. That's it. That's our answer. Next, number 6. The diagram shows this curve where is a positive constant and its maximum point m. Find the exact coordinates of m. Let's do this. So dy by dx is actually equal to 1 e to the power minus x plus x times minus a e to the power minus x. So just equate it with 0. Now we can take e to the power minus x common, so we actually end up with 1 minus ax. Okay, so this is not solvable, so we actually get ax is equal to 1, x equals to 1 by a. Okay, next let's find a y. Y is equal to x e to the power minus x, so y is equal to 1 by a e to the power minus a into 1 by a. We can get rid of this 1 by a e to the power minus 1, which is basically 1 by ae. So 1 by a and 1 by ae. That's it. So these are the coordinates of the maximum point m. Find the exact value of this. Fine. Let's integrate this. Okay. Integration by parts, yeah. So u is equal to x and dv by dx is equal to e to the power minus ax. So du by dx will be 1 and v should be this integration, which is e to the power minus ax divided by minus a. Let's do this. Okay, so let's do this. It's uv first. So x times e to the power minus ax by minus a, and over here we have to integrate this again, 2 by a 0 and then these two. Right? Okay. So I won't input the limits yet. X e to the power minus ax by minus a. Let's keep it. We'll input the limits at once. Let's integrate this again. So it's there should be a minus in here, yeah. So e to the power minus ax divided by minus a into minus a, which is plus a square. Okay. Or you could just put the limits together at once. There you go. Now let's go for it. 2 by a times e to the power minus a into 2 by a divided by minus a minus e to the power minus a into 2 by a divided by a square minus 0 plus e to the power 0 divided by a square. This is what we end up with. So after further simplification, it's actually minus 2 by a square e to the power minus 2 minus e square by a square plus 1 by a square. Okay. This should be a minus 2. Now we can take 1 by a square common. What do we end up with? Minus 2 e to the power minus 2 minus e to the power minus 2 plus 1. So finally, the answer is 1 by a square 1 minus 3 e to the power minus 2. And that is it. Okay, moving on to the next one. Okay, so show that cos to the power 4 theta minus sine to the power 4 theta is equal to cos twice theta. Let's do this. So this is basically, this can be written as cos square theta whole square minus sine square theta whole square. So that's a plus b. A square minus b square is a plus b, a minus b. Okay. Now we know that is sine square theta plus cos square theta is equal to 1. And on the other hand, you know that cos twice theta, right? It is three identity. You have three identities actually for cos 2 theta. So cos 2 theta is cos square theta minus sine square theta, 2 cos square theta minus 1, or 1 minus 2 sine square theta. So this can be written as cos 2 theta. That's it. That's literally it. Shown. Hence find the exact value of this. Let's do this. So we can just input this cos 4 theta minus sine to the power 4 theta as cos twice theta over here. And for this, what can we do actually? Let's see what's possible. We need to use a double angle formula basically. Okay. Because check this. We know that sine 2 theta is equal to 2 sine theta cos theta. Sine 2 theta is equal to 2 sine theta cos theta. And what do we have here? This is basically 2 sine theta cos theta into 2 sine theta cos theta, right? So what can we write really? Cos 2 theta plus, it's basically sine square 2 theta. This is what we end up with, sine square 2 theta. Okay. Now we have to apply the double angle formula again. How? Check this. We know that cos 2 theta is equal to 1 minus 2 sine square theta, right? This is from the data booklet. Sorry. Cos 2 theta equals to 1 minus 2 sine square theta. So can we write this? This is cos 2 theta, not cos square theta. So isn't this possible? Like, what if we doubled everything? So what would cos 4 theta be? It would be 1 minus 2 sine square twice theta. Essentially this is it, right? Cos 4 theta equals to 1 minus 2 sine square 2 theta. So if you make this is the subject. 2 sine squared 2 theta equals to 1 minus cos 4 theta. So sine square 2 theta is actually 1 minus cos 4 theta divided by 2. This is it. This was a bit challenging actually. So let's just substitute this inside. I'm gonna break it down actually to 2 parts. It's gonna be easier for me to do. I'm gonna take the half outside. Hopefully you guys understood. Awesome. Okay, now let's integrate. So this just turns into sine 2 theta by 2, and this part turns into theta minus sine 4 theta by 4. Fine. So now if you put this in, this is sine pi by 4 by 2 minus sine minus pi by 4 by 2 pi by 2 by 4 minus pi by 8 plus sine minus pi by 4 by 4. So this is root 2 by 4 wait, I got this, plus root 2 by 4 again. It's basically pi by 4 now. Minus 1 by 4 sine minus pi by 4. But I messed up here. It's pi by 2, right? 4 by 8, that's 2. Sorry. Okay, minus 1 by 4 again. So basically it's root 2 by 2 plus half pi by 4 minus half. So essentially we end up with root 2 by 2 plus pi by 8 minus 1 by 4. Root 2 by 2 plus pi by 8 minus 1 by 4. Yes, that is our answer. Moving on to question 8, vectors. The points A, B and C are position vectors this, where O is the origin. The line 1 passes through B and C. Vector equation for line 1. Okay. So let's find out BC first, which is OC minus OB. OC 8, 5 minus 3 minus OB 5, 2, 0. That's 3, 3 minus 3. So vector equation for line 1 should be OB plus anything like lambda maybe times BC. So 5, 2, 0 plus lambda 3, 3 minus 3. This is it, right? This is it. You could take the 3 out. That's also fine. That's totally okay. Okay. You could just write 5, 2, 0 plus lambda 1, 1 minus 1. That's okay. The line 2 has the equation this. Find the coordinates of the point of intersection. Alright. So this is the equation for line 2. It is minus 2, 1, 4 plus mu 3, 1 minus 2. So we can write like this. Minus 2 plus 3 mu, 1 plus mu, and 4 minus 2 mu. Okay. On the other hand, for line 1, it's like this. Let's just simplify it, okay? 5 plus lambda. I'm just taking the 3 out. Okay, you can do that. 2 plus lambda, and it's just minus lambda. You could do it with 3 too. It's fine. Now just make them intersect. Like I'll use the easy one. I'll use this. Minus lambda is equal to 4 minus 2 mu. On the other hand, 1 plus mu is equal to 2 plus lambda. So lambda is equal to 2 mu minus 4. 1 plus mu is equal to 2 plus 2 mu minus 4. So if you bring everything to that side and this over here, 1 minus 2 minus 1, okay, 1 minus 2 plus 4 equals to 2 mu minus mu. So mu is equal to 3. Okay, so lambda should be equal to 6 minus 4, which is 2. Now just input it inside. So the point of intersection is basically this. 5 plus 2, 7, 2 plus 2, 4, and minus 2. 7, 4, and minus 2. The question already implies that the line intersects, so we don't need to check, okay? That's the answer. Let's go next. So let's do this. So the point D on line 2 is such that AB is equal to BD. Okay, let's try to draw a diagram. So line 2, yeah. So line 2 actually starts, if you look at this, where does it start from? Minus 2, 1, 4. Minus 2, 1, 4, OA. It starts at point A. Okay. And D is maybe somewhere over here, okay? So D is such a point on line 2 such that AB equals to BD. So we can easily find out AB using OB minus OA, which is 520 minus 214. Seven, 1, minus 4. Okay. There you go. Then let's go. This is 49 plus 1 plus 16. That's root 66. Best. Okay, now BD. I need BD. So BD is OD minus OB. Okay. Let's find out OD first. So what is the OD going to be? OD basically lies on this line L2, right? So this is basically the equation for a point on line L2. So we can just write that this is OD. Fine. Now BD. BD is OD minus OB. So it's going to be minus 2. Okay, same thing again, right? So I'll just copy paste it. Minus OB, which is 520. Okay. So BD is basically minus 7 plus 3 mu, minus 1 plus mu, and 4 minus 2 mu. There you go. So what's the general idea? The length of this will be equal to root 66 as well. So let's do that. Come on. Let's go. So absolute value of BD. What will it be? Okay. Root over 3 mu minus 7 whole square plus mu minus 1 whole square plus 4 minus 2 mu whole square. Okay. So that's 9 mu square minus 42 mu plus 49 plus mu square minus 2 mu plus 1 plus 16 mu plus 4 mu square. Okay. So we ultimately get 9 plus 1, 10. That's 14 mu square. Then minus 4 to minus 2 minus 16. That's minus 60. Minus 60 mu. And over there it's 49 plus 1 plus 16, which is 66. Oh, okay. So this is the absolute value of BD. So we know that this is equal to root over 66 basically. And you can get rid of this. So 14 mu square minus 60 mu plus 66 equals to 66. Get rid of that. Then you get mu, or 2 mu I guess. So 7 mu minus 30 is equal to 0. So one of them is mu equals to 0, which can't be possible I guess. Let's see. And on the other hand we have 30 by 7. Can mu 0 be possible? Minus 214. No, it's not possible. It's not possible. So this is wrong. So it's mu is equal to 30 by 7. So what will the coordinates be for OD? Let's do this. So OD is equal to 30 by 7 into 3 minus 2. So that's 76 by 7. Then 1 plus mu, right? So 30 by 7 plus 1, which is 37 by 7, plus 37 by 7. Then 4 minus 2 into 30 by 7, which is minus 32 by 7. Okay, great. So that's that. Very weird answer, but this is correct. Okay, let's move on to 9. The complex number z and omega are defined by this. Express zw in this form. Fine. Z omega basically. So 1 minus I times minus 3 plus 3 root 3i. So that is minus 3 plus 3 root 3i plus 3i minus 3 root 3i square. So this is basically minus 3 plus 3 root 3i plus 3i. I square is minus 1 plus 3 root 3. So we get 3 root 3 minus 3 plus I 3 root 3 plus 3. This is basically it. Okay. Express z and omega in this form. Okay, so z first. Z is this 1 minus I. So r will just be 1 square plus 1 square root over answer, which is root 2. And if you draw z, it's essentially 1 minus 1 over here. So this is the argument. It's minus pi by 4. So for z is actually root 2 e to the power minus pi by 4i, right? Next, for omega, it's actually minus 3 plus 3 root 3i. So if you draw it, where does it lie? Minus 3 plus 3 root 3i. It's over here. So let's get this angle. So tan theta is equal to opposite 3 root 3 by 3. Tan inverse 3 root 3 by 3. That's pi by 3. So this whole angle, what will it be? Pi minus answer 2 pi by 3 plus 2 pi by 3. Yeah. So that's the angle. And what about r? R is equal to minus 3 square plus 3 root 3 square root of answer. 3 square plus 3 root 3 whole square root of answer. It's 6. So omega is actually 6 e to the power plus 2 pi by 3i. Okay, on an Argand diagram, the points are a and b respectively. Draw them. Fine, let's do this. Let's go. So omega, z omega. Okay. 1 2 3 4 5. 1 2 3 4 5. 1 2 3 4 5. 1 2 3 4 5. Okay. So omega first. I already drew the point. So we need to know what 3 root 3 actually is. 3 root 3 is 5.19. Okay. So it's 1 2 3 and 1 2 3 4 5.19. So somewhere over here, this is the point. Okay, this is minus 3, this is 3 root 3, real, imaginary. So this is the point A, and z omega, how much is it? This. So 3 root 3 minus 3, which is 2.2, 2.2 somewhere over here, and 3 root 3 plus 3, which is crazy, 8.2. That's so high up. Damn. Okay, I have a technique. Wait, I can just shift the whole thing down. 8.2, 6, 7 and 8. Oh damn it. 8. Okay. 2.2 and 8.2. 1 2 3 4 5 6 7 8. 8.2 somewhere over here. Okay, so there you go. So this is point B, and we have origin O. So what do we have to prove? That it's an isosceles right angle triangle. Fine. So let's do this. Okay. And last one. I'm not gonna lie, really nice picture. Fine. So clearly, this is the right angle, and these are the sides which are equal. So let's do this. So firstly, the value of AO. Okay, AO, that's basically, this is omega. We know that the value of omega is 6. And on the other hand, we need AB now. AB. What is AB basically? It's basically OB minus OA. So yeah, this, let's just use vectors. It's very straightforward. OB. So 3 root 3 minus 3, and over here it's 3 root 3 plus 3. OB minus OA. Minus OA, which is just this, minus 3 and 3 root 3 over here. Okay, so it's just 3 root 3 over here, and it's just 3 over here. This is AB. Now the absolute value of AB will be, I just use vectors, okay? 3 root 3 whole square. 3 root 3 whole square, which is 27, plus 9. That's 6. Okay, that's root 36, which is 6. So this is also 6. So we can write that AO is equal to AB is equal to 6. So we just proved that it's an isosceles triangle. Now about the triangle, sorry, the angle AOB, 90 degree. Okay. How to do this? So angle AOB, basically, look, which one is 90 degree? Clearly A, right? Clearly A. But it's hard to do. We can't really find that out. What we can do is, since we know that this is an isosceles triangle, if we just find out this angle over here, right? Check this. The trick is we are going to find out this angle. How? Is the argument of omega minus the argument of z omega. I'm going to find out angle AOB. Is the argument of omega minus argument of z omega. So argument of omega, how much was it? 2 pi by 3. Okay, and the argument of z omega, how much will it be? This. Okay. Oh, you can easily find it out like this. It's just tan theta is equal to opposite, which is 3 plus 3 root 3 divided by 3 minus 3. 3 plus 3 root 3 divided by 3 root 3 minus 3, tan inverse 5 pi by 12 theta. So that's pi by 4. There was actually another route you could easily just go for. Check this. Essentially, the argument of z omega. What is that actually? Argument of omega minus, this can be written as argument of z plus argument of omega. This is actually legit. So it's argument of omega minus argument of z minus argument of omega. So you can actually get rid of this and just end up with minus argument of z. And you know that the argument of z is pi by 4, right? We found that previously. It's minus pi by 4. So minus into minus pi by 4 is actually plus pi by 4. So that's an alternate route of doing this. So since this is pi by 4, this also has to be pi by 4. So angle OAB must be 90 degree. So we can write that AOB is equal to ABO is equal to pi by 4. Therefore, OAB is equal to pi by 2 or 90 degree. Okay, so that's our proof. Complicated. Using your answers to part B, prove that tan 5 pi by 12 is equal to root 3 plus 1 divided by root 3 minus 1. Okay, so this is the one I just showed on the right hand side, right? We know that argument of ZW is equal to argument of Z plus argument of W. Okay, so I'm just using the answer from part B. This one. The answer from part B. Z and W. And we know that this is 5 pi by 12. The argument of, we know that the argument of Z omega is 5 pi by 12. I found that out in part C. So I'm just going to use that. Okay. So let's do this. So argument of Z omega is equal to argument of Z, which is actually minus pi by 4, and argument of omega, which is 2 pi by 3, right? 2 pi by 3. So argument of Z omega is equal to 5 pi by 12. I actually did that beforehand, so it's fine. Now, here's the thing. This part that I did over here, right? We can also say that argument of Z omega is equal to tan inverse opposite by adjacent. Okay, opposite is 3 plus 3 root 3 and adjacent is 3 root 3 minus 3. I showed this to you guys beforehand. So we know that this value is 5 pi by 12. So you can bring tan to the left hand side. Tan this is equal to, you can take 3 common. 1 plus root 3 divided by 3 root 3 minus 1. So you can get rid of this. So finally tan 5 pi by 12 is equal to root 3 plus 1 divided by root 3 minus 1. That is the answer. It's shown actually. Okay, so a tricky sum overall for complex numbers, but doable. Next, number 10, last sum of the day. By writing y is equal to sec cube theta as this, show the dy by, okay, so y is equal to sec cube theta or cos minus 3 theta. So dy by d theta equals to minus 3 cos minus 4 theta, and cos theta, the differentiation is minus sin theta. Yeah, okay, now what, this is minus 3 cos to the power minus 4 theta, sorry, this turns into plus times sin theta, or it's basically 3 sin theta by cos to the power 4 theta, which can be written as 3 sin theta sec to the power 4 theta, shown. Okay, let's go to the next part. It's a differential equation, so let's do this. So the idea is, since d theta is on top, only the thetas can be on the left hand side. So sin theta by cos to the power 4 theta d theta is equal to x plus 3 by x square plus 9 d theta. Now see if it matches. What do we have on this side? Sin theta sec to the power 4 theta. Does it match? We need a 3 over here. So if I multiply a 3 on this side, I need to multiply a 3 on that side as well. So this turns into, I'm going to split this up actually. This turns into 3x divided by x square plus 9 plus 3 to the 9. 9 divided by x square plus 9 d theta. Fine. So this is pretty straightforward. Since the differentiation of this is this, the integration of this will be just sec cube theta. So we can get sec cube theta over here. And for this, I'm just going to take a step. Why? Look. You know that the differentiation of x square plus 9, what will it be? Twice x. Do we have 2 on top? No. So what I'm going to do is I'm going to take 3 out and I'm going to introduce a 2 on top. And since I introduced 2, I need a 2 outside. There you go. So it should be dx here, right? My bad. Dx on this side. Dx. Okay. There you go. And for this, what should it be? This is the one for tan inverse. So I take the 9 out and I write this as x square plus 3 square dx. What am I using? I'm essentially using this, okay? I know that the differentiation of tan inverse x is 1 by 1 plus x square. So the integration will be something like this. If you integrate this, look, you can take the 7 out and you can write this as x square, and 8 is root over of 8 is 2 root 2. So 2 root 2 whole square. So the integration will be tan inverse this x divided by 2 root 2, the root over version, and outside in the denominator you will have the 2 root 2. So similarly, if I apply the same idea, the same concept, check this. Sec cube theta is equal to 3 by 2. This one will simply be ln x square plus 9 because the differentiation of this is twice x. And over here it's going to be 9 divided by 3 tan inverse x by 3 plus c. Okay, so it's sec cube theta equals to 3 by 2 ln x square plus 9 plus 3 tan inverse x by 3 plus c. Now we have some info given that when x is equal to 3, theta is pi by 3. Let's go. So this is 1 divided by cos cube pi by 3 is equal to 3 by 2 ln 9 plus 9, which is 18, plus 3 tan inverse x by 3. 3 by 3. Okay. So cos pi by 3 cube, 1 divided by answer, That is 8 is equal to 3 by 2 ln 18 plus 10 inverse 1 pi by 4, 3 pi by 4 plus c. So what do we get? Therefore c is actually equal to 8 minus 3 by 2 ln 18 minus 3 pi by 4. Okay, so what do they want actually? Find the value of cos theta when x equals to 0. Okay, we got this. Come on. So just write this again. Get rid of this and write this over here. Okay, so find out the value of cos theta when x equals to 0. So x equals to 0, so let's just do it. 1 divided by cos cube theta is equal to 3 by 2 ln 9 plus 3 tan inverse 0 plus 8 minus 3 by 2 ln 18 minus 3 pi by 4. Answer to 3SF. Okay, so let's just do this at once. 3 by 2 ln 9 plus 3 tan inverse 0 plus 8 minus 3 by 2 ln 18 minus 3 pi by 4. Wait, sorry, I messed up. Okay, so I'm getting this 4.60408. So what will it be actually? Cos cube theta is equal to 1 divided by 4.60408. So cos theta is equal to cubic root of this 1 divided by answer and cubic root of answer. That gives us a value of 0.601 to 3SF, and yes, that matches with the mark scheme. Yes, so yeah, very hard question. We had a few hard questions here and there, but we are officially done with this paper. I'm gonna be launching paper 3.1 and 3.3 soon, so don't worry, more P3 content rolling out and more P3 after the October-November 2024 papers are out. Okay, don't worry, and happy new year guys. And if you're interested, please do join my classes that are starting from February. I'll drop a link in the description. And quick shout out to my top tier patron for the month. He's been supporting me, Nigel. Thank you so much for supporting me. If you want your name to be featured on the end screen, please consider supporting me on Patreon for one-on-one meetings. Anyway, that's been it. So when I'm done solving them, I'll attach May-June 2024 paper 3.1 up here and the paper for May-June 2024 3.3 down here, and the playlist for the pure math 3 playlist up top. So remember to hit the subscribe button. See you guys. Bye bye.